Hello children, welcome back to our physics class. I hope you're all doing well and ready to learn, explore something new today. Well, in today's class, let us discuss something very important topic in physics. In light, we will be discussing the reflection due to curved mirrors. Reflection on curved mirrors. We also try to get the relation between the focal length and radius of curvature and also the mirror equation. We also extend our topic regarding the magnification. So, let us start with first one, all regarding the reflection on curved mirrors. Here we go. So, first of all, what is a curved mirror? A curved mirror is a portion of a hollow sphere. So, first of all, let us consider a hollow sphere. Let us imagine this as a hollow sphere. Yes. So, on this hollow sphere, so you have to imagine a sphere, a spherical shaped ball. So, you know the rubber ball that you are be playing, which is hollow, or a football or a basketball which is hollow inside. Okay. So, you have to imagine a glass of that spherical ball, glass ball, spherical glass ball which is hollow. Okay. So, it is a 3D picture, out of which let us suppose that a small portion of the ball is being cut. This is your complete ball. From this complete ball, a small portion of this ball is being cut. Okay. So, something like this you will be getting. From the complete ball like structure, you have to cut a small portion. So, if you consider only that small portion of this picture, so and if you coat it, if it is silver lined inside, this will be the reflecting part, outer region will be the reflecting part, the convex mirror. That case is called as convex mirror. The same mirror, if you silver lined outside, then the light will be reflected from this curved, that is concave shaped mirror. Hence, that is called as a concave mirror. Let me explain this in detail. So, let us consider a spherical glass ball made of glass, out of which let us cut a small portion of this, is being cut. This portion is being considered. It is not a silver lamp because it is a mirror, it will be extended part. So, something like this. Yes, a small portion of this mirror is being cut as shown in the picture. So, this is a glass sphere, a hollow sphere made of glass, out of which a small portion is being cut. So, now let us focus only on that small part. Then suppose this one, if it is coated outside, if it is coated from outside, then the inner region, whenever the light falls on this outer part, it will get reflected, something like this. The light gets reflected. The portion of the image, the portion of the mirror which reflects the light will be from inside portion of that. So, this portion which is silvered outside, and the hollow one, if it is reflecting the light ray falling on that, that type of mirror is named as your concave mirror. What is that named as, children? Concave mirror. That means, so this curved mirror is a part of a hollow sphere. Okay. If this reflection takes place from the inner surface, if the reflection takes place from the inner surface, this type of mirror is named as your concave mirror. The same thing if the reflection takes place from the outer surface. Suppose if the reflection takes place from the outer surface, that means if it is silvered inside, then all the light rays falling on that will be reflected by the outside portion of the mirror. Okay. So, if the reflection takes place from the outer portion of the mirror, then this type of mirror is named as your convex mirror. This is named as your convex mirror. I hope you understood the difference between the convex mirror and the concave mirror. So, first of all, you have to consider a big hollow sphere made of glass. So, a sphere, a spherical shaped hollow sphere made of glass, hollow spherical, out of which a portion of the glass is being cut. Let this be the portion. If it is coated outside, if it is silver lined outside, all the light rays falling on this mirror will be reflected by the inner surface of this mirror. Hence, this type of mirror is named as concave mirror. So, this one, because it is coated outside. The same thing, same mirror, if it is coated inside, all the light rays falling on this mirror will be reflected back by the outer region, because it is coated inside. Okay. So, that type of mirror which reflects the light by the outer surface of the mirror, that mirror is named as your convex mirror. So, this is your concave mirror, because inner portion is reflecting the light, and this is your convex mirror because outer portion is reflecting the light. So, let us try to understand the parts of this mirror one after the other. First of all, if this happens to be a mirror, a curved mirror, there will be some center point of this mirror. And this center point, the midpoint of the mirror itself, is called as pole or vertex. So, first one, all about your pole or vertex. So in this mirror, the center point of the mirror is named as your pole or vertex. This portion, this point itself is called as pole or vertex. Suppose if the mirror is very thin, then it will be shown something like this. This is called as your pole of the mirror. The midpoint of the mirror is called as your pole of the mirror. Whether it happens to be a concave mirror or a convex mirror, pole is nothing but the midpoint of this mirror. Fine. So first one is all about your pole. Midpoint of the mirror. Next one is all about your principal section. So this portion which passes through the pole of the mirror, this complete portion itself is called as, the portion that passes through the pole of the mirror is called as your principal section. Any section that passes through the pole of the mirror. Next is all about your center of curvature. Earlier we said that this mirror is a portion of a big sphere. Well, so out of this complete sphere, a portion of which is been cut. Okay. And hence, suppose if you produce this complete picture, then no doubt you will get a circular region. For this entire hollow sphere, there will be a center position. For this complete hollow sphere, there will be a center sphere that is called as the center of this complete hollow sphere. So that center of the hollow sphere when produced, that center of the hollow sphere when produced itself is called as center of curvature of the mirror. So this is actually the hollow sphere which we have considered, the very initially whatever we have considered. So for that hollow sphere, some center will be there. So that center, the center point of the complete sphere is called as your center of curvature. So for that complete sphere, the center point whatever is there is called as your center of curvature C. Okay, and this is the principal section or principal axis. Principal axis is different and principal section is different. Well, so if this mirror is produced continuously such that initially some hollow sphere is there, that center point itself is called as your center of curvature. That is the center of sphere. Well, now about the radius of curvature. Radius of curvature, center of curvature generally indicated with the letter C, pole of the mirror indicated with the letter P, Radius of curvature indicated with the letter R. The distance between the center of curvature and pole of the mirror. The distance between the center of curvature and pole of the mirror is called as radius of curvature. So, what is that, children? Distance between center of curvature C and pole of the mirror P is called as your radius of curvature. Next, principal axis. As I told you that the complete line itself, from that line joining the center of curvature and pole of the mirror, this complete line produced in both direction, that complete axis itself is called as your principal axis. This is called as your principal axis. The line passing through the center of curvature and principal axis is called as your, center of curvature and pole of the mirror is called as your principal axis. The pole and center of curvature. Well, principal focus. Next is all about your principal focus. The light, the parallel beam of light after passing through parallel to the principal axis, a parallel beam of light after striking the mirror will reflect back into the same region in the case of a concave mirror. Concave mirror means it is coated outwards. Whereas the light ray passing through the center of curvature is again reflected back in the same direction. Okay. So, the place at which these 2 points are meeting is called as sorry children. So, whenever a parallel beam of light rays passing through the a beam of light passing parallel to the principal axis cuts the principal axis at a point, and that point itself is called as your focus. That point itself is called as focus. Well, so this focus will always be at the center of the P and C. It's always at the center of the P and C. Okay. And the length from F to P, the length itself is called as your focal length. The distance between the focus and principal and the pole of the mirror is called as your focal length, and the length from center of curvature to pole is called as your radius of curvature. Okay, indicated with the letter R. So, based on that, and one more thing children, aperture. This line that joining the two ends of this mirror, this line itself is called as a aperture.